Today's determined attackers easily bypass even the most advanced network defenses. Trying to ramp up staff to detect their backdoors can cost thousands of dollars and take months, even years. With Active Countermeasures AI Hunter, we enable junior analysts to detect even the most advanced backdoors in a matter of hours. Sign up for a demo and purchase our product today by visiting activecountermeasures.com/PSW. Active Countermeasures. Make every analyst a hunter.
Endgame's converged endpoint security platform is transforming security programs, their people, processes, and technology with the most powerful endpoint protection and simplest user experience, ensuring analysts of any skill level can stop targeted attacks before information theft. Endgame unifies prevention, detection, and threat hunting to stop known and unknown attacker behaviors at scale with a single agent. For more information, visit endgame.com. Organizations' internal networks are overly permissive and can't distinguish trusted from untrusted applications. Attackers abuse this condition to move laterally through networks, bypassing address-based controls to spread malware. Edgewise abstracts security policies away from traditional network controls that rely on IP addresses, ports, and protocols, and instead ties controls directly to applications. Edgewise allows organizations to analyze the network attack surface and segment workloads based on the software and how it's communicated. Edgewise monitors applications and protects data paths using zero trust segmentation. Visit edgewise.net/Security Weekly to get your free month of visibility. Some restrictions apply. Welcome back, everyone, to Paul's Security Weekly. Excuse me, I'm really excited to tell everyone about a webcast that I'm doing with Rod Simmons from StealthBits. We actually just had a call today, and a lot of really cool talking points. It's kind of like Rod's got really good slides, and I basically have multiple points where I'm pretty much just like telling a story and adding some context to it. And I think it's going to be really fun and educational. So make sure you go to go.stealthbits.com/2019 trends. Register for our webcast titled Emerging and Continuing Trends in 2019. We're going to talk about privacy regulations, Active Directory security, and machine learning. It's really cool. I'm excited. And now Marcelo's with us. Marcelo, welcome.
Hello.
Back. And again, I mean, you were here before, but now this is your segment. So
hey,
welcome to your I'm going to shut up now so you can talk. How about that?
Well, shouldn't we introduce Marcello? Nobody knows who he is.
That's good.
Yeah, my prompter's not working. That's why. That's my excuse.
Well, Joff, introduce the good man.
Yeah, Joff. That's a good idea.
I will. Okay. So Marcello is an awesome employee of Black Hills Information Security, security analyst, researcher, pen tester, and he and I get along famously because we like coding weird things to aid in our pen testing efforts. Marcello's done a number of wonderful talks, both at, I believe, DerbyCon and Wild West Hacking Fest. Am I wrong on DerbyCon? Check me, Marcello.
Yep, DerbyCon.
All right, yay. So without further ado, let's bring Marcello to the table to show us some cool stuff.
Well, it's funny that you mentioned that, because speaking of coding weird things, I got something weird to show you. And we also talked about .NET. Let me see if I can share my screen here without breaking everything. Okay, can everyone see my screen?
Yes.
Yay, yes.
Awesome. Okay, so
the irony, we were just talking about SilentTrinity at work today.
Well, there you go. Well, this is going to be perfect then. So I love coding weird things, and this is really, really freaking weird, and it involves .NET too, which is awesome. So this tool is basically my attempt at solving the red team tradecraft problem of gaining dynamic access to the .NET API without going through PowerShell in any way. So the reason why we love PowerShell offensively is because like you can do all the good stuff without touching disk at all, right? So you can invoke Mimikatz, you can use PowerSploit, all that good stuff. And the reason why PowerShell really is powerful, unintended, is because of the underlying access that it has to .NET. So the problem with Microsoft implementing all these PowerShell defenses inside PowerShell really cut down on that, right? And I wanted a way of not worrying about all those protections like AMSI, script block logging, constrained language. I didn't really want to worry about any of that. I didn't want to obfuscate PowerShell scripts. I hate obfuscating stuff, I'm not going to lie. So I just wanted a way of bypassing all of that. And it turns out there's this thing in .NET called the DLR. So there's the CLR, the Common Language Runtime in .NET, and then there's the DLR, the Dynamic Language Runtime in .NET. And from at least my understanding of the Dynamic Language Runtime, it's basically a way for scripting languages to interface with .NET. So you can build scripting languages yourself that interface with .NET, and those scripting language can, like PowerShell, can dynamically call .NET APIs, and that's where the real power in PowerShell lies, right? So I started researching this, and it turns out there are a bunch of languages that are implemented on top of the .NET framework. One of them is IronPython, but there are many others. There's IronRuby, there's Booleang, which I recently discovered. If you haven't looked at Booleang, it is freaking amazing. And at the time, I started researching this, and it turns out that you can do some crazy stuff with it. Specifically, you can embed an IronPython engine within a C# binary. And what that allows you to do is all of a sudden is to have a way of natively executing IronPython scripts without actually installing IronPython on the endpoints, because obviously, like, you're not going to be calling the people up and saying, "Hey, can you install IronPython on your endpoints so I can, run my malwares and stuff?"
So wait, Marcelo, you jump from .NET to C#. So what's the initial binary, or what is the initial payload consist of that you're putting on the system?
Well, it's interesting because since the .NET framework can interface with so much stuff, you can. And basically, the initial it can be it can be a lot of things. Right now in SilentTrinity,
Marcel, let me ask a question a different way. Yeah. Is the .NET is it interpreted or compiled? It's interpreted, right? .NET, is it interpreted language?
Well, C# is, but if you go through the DLR, it's now a scripted language. You can interface scripting languages to .NET. So that's what IronPython is. IronPython is basically just a scripted interface to the .NET framework.
So natively in Windows, without installing any additional tools, what languages can it either run or interpret?
Well, this is the thing. Because IronPython and all the Iron languages are interfaceable with the .NET DLR, you can embed the engines of those languages itself inside a C# binary. Mm-hmm. So the initial payload, like SilentTrinity has a couple of stages right now. It has an XML, MS Build XML payload, which goes through a lot of EDR solutions, and it's also a whitelisting bypass. And there's C# source code inside that XML file that gets run automatically when you call MS Build, and I'm going to demonstrate this in the demo.
Okay,
and
I think that would help.
This is, it's hard to visualize. So this is why, like, I created a graph because I've had a lot of people really, really confused on how this works.
Okay, so it's good to know I'm not the only one. Anyway,
nice. No. So Marcelo, from my perspective, the engine itself. Is it just a DLL that's embedded in there, or what is the engine that's embedded in the C# code?
So it's a .NET assembly, which is basically
it's an assembly. Okay.
Yeah, it's an assembly, and for the engine to actually work, it needs 4 assemblies. It needs Microsoft Dynamic, Microsoft Scripting, IronPython. .dll and IronPython modules.dll, if I recall correctly. And these aren't natively installed on Windows, but through a little C# trickery, you can make .NET automatically resolve them at runtime, either to a URL or either embedded as a resource within the C# binary. If that makes sense.
Carry on, sir.
So the great thing about this is, by executing IronPython through a C# binary, you now have all the power of PowerShell without PowerShell and in Python. So you can. So the way SilentTrinity works is, and I'm not sure if this is. I'm going to make this bigger. How about that? So the way SilentTrinity works is there's a Python 3.7 server. It sends down a stage, which is just a zip file at the moment, and it contains all of the DLLs necessary for that C# engine to load, the IronPython C# engine to load. And it also includes a a main.py file, which is essentially the payload code. So the actual payload code is actually never on disk because it's just a Python file. It's only in memory, which is another great, awesome feature of doing it this way. So it sends down the stage, C# binary or whatever the C# binary or assembly is embedded in, resolves the assemblies in that zip file at runtime, loads the IronPython engine and executes the payload code. And then the payload code starts calling back out to our C2 server to ask for tasks, right? Which again is just a Python file. It's literally job.py that it gets sent down. And this is where Microsoft, the DLR is just an amazing technology. This is where things start getting complicated because you can do, in IronPython specifically, you can do something which I've termed engine inception. So you can actually embed an IronPython engine within an IronPython engine within an IronPython engine. So like, yo dog, I heard you like IronPython engines, right?
So I put an IronPython in, yeah.
Yeah. So what I made it do is basically I made it spin up a separate IronPython engine just to execute the job and then spit back the output to the C2 server. And this actually, from a programmatic standpoint, this has a number of advantages, which I think is beyond the scope of this, but it allows you to isolate like the dependencies that a job needs and all that stuff, which is amazing too. And you can do crazy stuff with this. Like I have a Mimikatz module. So basically you ever wanted to like invoke Mimikatz in Python, in IronPython, and it calls the same .NET APIs as invoke Mimikatz does basically. So I'm going to demonstrate that now. How about that? Because seeing is everything.
Seeing is believing.
Yes. Okay, so I have my terminal here. The font is probably way too small. I'm just going to make this bigger. How about that? Can anyone see that?
A little bigger.
Yeah,
bigger.
A little bigger.
Bigger. Bigger.
Bigger?
That's not bad.
Yeah.
Whoa. That's big enough.
Too big.
That's big enough? Too big? Okay, wait.
That's good. Perfect.
Okay, sweet. Okay, so if you download SilentTrinity, it's on GitHub, open source. You install the dependencies. There's a decent install guide right now. I haven't had time to flush out the documentation as every other open source project. All you really need is Python 3.7, and you can start up SilentTrinity using the st.py file. You can also give it a resource file, which I'm going to give it now. So if you're familiar with Metasploit resources files, and it just executes a bunch of commands in Metasploit on startup, that's basically what this is going to do. And it's going to, the font's really big, but it's going to start a listener. So this is just a regular HTTP listener on the natted IP address, VM natted IP address. So now we have a listener running. And now we have to generate a stager, right? So we actually have to get the malwares on the endpoint. So we go to stagers, you type list. Right now there's only two stagers. One uses Wimic, which is another sub-T discovery. This is Squibbly 2. You know what Geoff was talking about, Squibbly 2? This is it. Yeah, there you go.
Yeah.
This is the Squibbly 2. This is the Squibbly 2 stager. That actually gets picked up by Defender by default. So I wouldn't recommend that, but I put it in there because it has a lot of stuff that it does, which is cool. MS Build, however, which is another sub-T discovery, the MS Build basically embeds, and this is where .NET is like insanely powerful. You can embed the actual C# stager within the MS Build XML file, and if you call MS Build and give it the path to the XML file, it will execute that C# stager. Okay,
so cool. It is so beautiful.
It really is. So I'm just going to use the MS Build stager, and I'm going to use the generate command and just give it the name of the listener, which in this case is just HTTP, and now it's all fine and dandy. So it generated the MS Build XML file, and this is the command that you need to execute on the endpoint in order to run it. So it's calling the msbuild.exe binary, and you just have to give it the path to the MS Build XML file that it spit out. So I already copied this onto my VM here, so I didn't have to fiddle with that. This is the MS Build file. And let's take a look at this real quick because it'll Oh, wow, that's not going to work. How about, or maybe we can. Let's see if PowerShell ISE.
WordPad and WordPad.
Oh, do you know what? You know what? Wait, let's go back here. Oh, wait. Hold on.
Yeah.
MS.
That cursed decision of carriage return line feed versus line feed.
Yeah.
All right, make the font bigger if you're going to do it here.
Oh, yeah. I'm just opening the MS build file up, which should be here, but it is not. Okay. Well, I guess I won't be showing you that. But you take my word for it. It's basically...
Never mind the man behind the curtain.
Yeah, never mind that. But if you open this up, what it is, if this showed you a little bit nicer, it's basically just C# code, raw C# source code within an XML file, and MS Build executes that on runtime. So I'm just going to go back to SilentTrinity here. I'm going to copy and paste literally the thing that it gives you. Bring that over to here. I just have a PowerShell command prompt here running as admin because I want to show you Mimikatz and stuff. And notice that everything is turned on in terms of Defender, except for automatic sample submissions because I don't need Microsoft looking at my malwares. So I'm going to run this, and you see that MS Build executed, and it automatically resolved. It downloaded the zip stager. It automatically resolved all of the assemblies needed to start the IronPython engine, and now it's beaconing back. So let's go over to SilentTrinity, and we see we have a new session here, which is awesome. If you go over to it actually has some stuff which I sort of got inspired from Cobalt Strike. So it actually tells you the last time it checks in. So like if you notice here, the last check-in is like 2 seconds, which I think is pretty cool. But now the fun stuff begins, because if you go over to the modules, you now have a bunch of modules that you can execute. And again, like no PowerShell is used in any of this. These are just literal Python, IronPython source files that get sent down to the C# binary. And I'm just going to use just, pop a message box real quick. So message box. What? Options. Okay. So you got the title of the message box. I'm just going to run this. And if we go over here, once the beacon checks in again, there you go. So we now have dynamic access to the .NET runtime without going through PowerShell in any way. Okay. And this also allows us to do stuff like Mimikatz. And I'm just going to run this. And this will reflectively inject Mimikatz within an IronPython engine, which is embedded in another IronPython engine, which is executing from an XML file with C# source code. And the IronPython engine is embedded in that C# source code. So think about that for a second, and your mind starts exploding.
Yep, pretty much.
And there you go. So we got Mimikatz output. So we got Mimikatz working. That's awesome. And there are a bunch of other modules in here that most of them I didn't actually write. What's great about these is that we got some really cool stuff. Like there's a module in here called internal monologue. If you haven't heard of internal monologue, it's essentially an attack that allows you to query LSASS without actually, I'm going to butcher this explanation because I don't particularly understand how the hell it works. But essentially, without touching LSASS, it basically calls a Win32 API that allows you to get the current user net NTLM v2 hash. If you're admin, you can actually perform a downgrade attack and get the current user's net NTLM v1 hash, which can be more easily cracked than the previous version. I want to run that real quick. And these are all the options. The font is extremely big, so this might not look that pretty. Run that. You see it running job over here. So it received it just raw Python file, and there you go. This is the output of internal monologue. And in the back end, what this module is doing in particular is it's actually running a C# assembly. So it's a C# binary, essentially, base64 encoded in the IronPython file, and it just runs it on runtime. And we can do that because of IronPython's interface with .NET. And this is completely in memory. And this pretty much goes through everything with like EDR solutions will usually pick up on the heuristics of like touching LSAS and just like dumping clear text credentials. Internal monologue bypasses that because since it just queries an API as opposed to actually dumping memory from the LSAS process.
So that doesn't touch the LSAS process in that method to get the hashes?
From my understanding, no, it does not. And if you go on GitHub, he has an insane explanation of it. Like he steps through on the GitHub project, he steps through every single thing that is required to perform this attack, and it's insane. I barely understand it. Like it's black magic.
Oh, well, that explains it.
That explains it. Yeah. No, it's a crazy attack.
Well, I mean, it's crazy.
Now I know why you were talking about it.
Now we know.
Now we know.
And this is just the tip of the iceberg, by the way. Like yesterday I actually published some research. It's another offensive DLR. It's on GitHub, and basically I embedded a Boolean compiler, which is another scripting language for .NET, within PowerShell. So, like with PowerShell, you can just dynamically compile and run Boolean, and then inject shellcode through the Boolean script within the PowerShell script. Like it's just crazy.
Inception,
like
for
.NET
sure.
is just absolutely nuts.
Marcelo, what would you see as a process running on the system?
In this particular case, you'll see the signed by Microsoft MS Build executable.
Wow.
You'll see.
Because MS Build is just executing a script.
Yeah. So, and this is Subt's discovery. Basically, there's this thing called inline tasks in the XML file that you give MS Build, and you can execute C# code source directly from MS Build.
Yeah, that is pretty amazing too. IronPython's one excellent effort by Marcello to do that, but you can use it standalone as well. I used it for a malware delivery mechanism this week, and it was absolutely fantastic.
Yeah. I mean, you don't need to use it like with Silent. You can just take the samples that are online, and you can just like embed your custom C# source. Like you could just use it completely standalone.
So you're not going to see anything in memory much. Are you going to see anything in the file system? It seems like almost nothing.
You won't. So this is where things, in terms of detection, this is where things start getting a little funky, because right now there are, well, that actually changed like the other day, but with default versions of .NET on Windows as of right now, there are no optics in the CLR or DLR at all. So this goes through everything. A couple of days ago, Lee Holmes announced .NET 4.8, which actually has AMSI integration for .NET. But there are a number, like, it's great, like it's an awesome step forward, but the time that it'll take for organizations to actually update their .NET frameworks on all their endpoints, that's gonna be a problem. And also, like, I'm pretty sure there's a way of getting around the AMSI thing in .NET. There are already a couple of researchers that are doing the work.
Wow. And just FYI, by the way, on internal monologue, one of the mechanisms that internal monologue uses here, as I understand it, is to actually impersonate all of the tokens of the associated users and actually perform a challenge response for each of those users. So that's why it's not touching LSAS, because it's actually challenge responsing. That's not even a word. Performing a challenge response for each associated user in that context. So it's a token impersonation style attack, if you like.
Yeah, exactly. And the great thing about it is, if you're admin, you can do the downgrade attack. That'll give you a net NTLM v1 hash. And since that's based on DES, if I recall correctly, they actually, the crack.sh, it's a website. It created the complete rainbow tables for a net NTLM v1 or something like. I'm not a crypto guy. I don't know what the hell I'm talking about.
But it's non-salted. That's the thing about v1, right? It's so we're static hash to static password.
Something like that. And so you could just literally copy and paste the net NTLM v1 hash that you get from internal monologue into this website. It'll give you the clear text password. Done. Like it's basically like Mimikatz at that point.
Now, I take it many people don't disable NTLM v1?
Well, it's not that they don't disable it. It's just because since you're administrator, you can
downgrade.
Just downgrade it, and it's doing it. I don't know exactly. Maybe Joff probably knows this.
Can you disable the downgrading feature or?
No, it's I don't think you can. Not that I'm aware of, at least.
That's interesting.
I don't think you can disable downgrade NTLM v1 because I don't know the because, but I'm not sure that you can.
I think it's literally a registry setting. I think like you just set a registry. If I recall correctly, I might be wrong, but I think you just literally set a registry key, and all of a sudden now you can get net NTLM v1 hashes.
If we had one of the people that taught 504, they'd probably tell us off right now. But anyway.
Now, this msbuild.exe, that's on every Windows system by default?
Yep. Absolutely.
And
that's the cool thing.
And would people remove that? Or if you did, would that break all their applications, I would think? Potentially.
Yeah, I would not touch anything. I mean, I'm not sure, but if I was a betting man, I would say if you remove that, that would break a lot of things.
I bet it would break a lot of installations, because my bet would be that a tremendous number of products are using MS Build for installation of .NET-based framework products.
Mm-hmm.
And
yes,
you'd get yourself into all kinds of trouble. But that would be an interesting thing to do, because we have some customers that are brave enough to take that step, actually.
Right,
so
right.
I might lay that challenge down.
Yep. And this technique right now bypasses a lot of, I don't know if I should say the names or not, but this bypasses like a lot of whitelisting EDR products out there.
That's a good, that's a good thing to say.
That's fair.
Yeah, that's fair.
Okay.
No, I think that's fair too. I mean, msbuild.exe is usually allowed. There are some people that have done the hard work of blacklisting everything, including Microsoft products, and then come back through the very long, dark, and narrow winding tunnel of making things work again. But that, I would say, is the minority and not the majority of folks out there. The majority of folks have gone through a less rigorous process.
And Marcelo, did you present this at DerbyCon or?
Yeah. The talk was IronPython OMFG.
Okay. That's really awesome.
It was a very well attended talk, by the way. He had a big crowd there, and much appreciated. Did a lot of modules come out of that talk?
There are a couple of people who were really into it and contributed like 3 to 4 modules, a lot of pull requests. Like, it's great. There are a couple of them that I haven't had time to get to. Hopefully over the holidays I'll be able to flesh things out. And I'm also going to
when you're resting, right?
Yeah. It's like I don't have time. I wish I had infinite time. But yeah, I have a lot of plans for this, because the capability, like the implementation and the ability to do this is crazy. And I want to add like crypto to the C2 channel, a lot more modules. Like, I want to add a bunch of stuff. You can even interface with Excel. Like, there's a module right now because you have access to .NET. You can interface with COM. So that means that you can dynamically create Excel macros and execute shellcode through the Excel macros, which is absolutely crazy.
And has anyone presented to you a defense where you're like, oh, yeah, like if they did that, that would be bad for me?
I don't think so. But and this is one thing I'm not a good forensics guy. I'm pretty sure there is a really good way of detecting this. Like there has to be. The only thing I can come up with right now is that if you see processes that have the Iron Python DLLs in memory, that's a good detection.
That's a pretty big sign. Yeah.
Well, what's crazy about that too is that 2 of the DLLs that this thing needs are signed by Microsoft. So that's another thing too. So like that there isn't really a lot to go up.
I mean, other than removing MS Build, but that could be problematic.
Well, here's the other thing. The runtime of MS Build is another thing that's actually legitimate here. I mean, if you see an MS Build that's persisting for 48 hours, you know, that's either a hung installation or a C2 channel, right?
The thing is, like, you don't necessarily need MS Build either, because again, like, because .NET is so tightly integrated in Windows, you can use PowerShell for a stager. Like, yeah, I already have, there's proof of concept code on my GitHub that runs the Iron Python engine within PowerShell. So like, you can use PowerShell, you can use Wimic, anything that has interfaces with .NET, you can probably get the SilentTrinity stager to run.
So what happens if we can't download the DLLs, if for whatever reason the internet path to not to get those Python DLLs is blocked?
Yeah, then it dead. It dead, Jim. Like yeah, it needs a
Well, I was thinking, could you create a recovery that then tries to use another mechanism instead of Python to
yeah, absolutely. Because this is another, I don't think a lot of people know this, but like in C#, you can hook the app domain on resolve event, which is basically the event that tries to resolve the necessary assemblies. So you can tell it to, hey, if you don't find my assembly in the zip file, like go out and make an HTTP request to this URL and try to download it there. Or like basically you can put any logic you want in that event, and you can customize the way like the assemblies get resolved. It's amazing.
So you could have like multiple options. That would be kind of cool.
Yep.
Yeah.
Yep. And few channels. The problem right now is actually .NET is a little far behind in the protocols that it supports, and by that I mean like it doesn't support HTTP2 yet. They're working on that. I don't know if the newest .NET release supports that yet. There is a native WebSocket module. So technically you could create like a C2 channel with this through WebSockets, which I think is pretty cool. Yeah, they just have to catch up. Once they implement that, like you can add all the comms in here, and it's really flexible. Like the whole system is insanely flexible.
Yeah, let's authenticate the perimeter, please.
Nice.
It's good work, Marcello.
Yes,
really, I really
awesome.
like what you're doing, man. But I already know that. Actually, the first time I've actually seen him talk about it, because we haven't had the time to talk about it, which is crazy. But anyway.
I know. And we work together. That's really weird.
And we supposedly work together, yeah.
Yeah.
Awesome. Well, Marcelo, thank you so much.
Yeah.
And now we're gonna have do the technical segment with Lenny Zeltzer, right? Did I get that? I get that right? Yes.
Or
okay.
something.
Enjoy it. It's awesome.